Good evening, my 11th standard warriors. Welcome to the fourth session of Newton's laws, where we are going to talk about non-inertial frames of reference and pseudo-force, all with me, Shreyas, your physics master teacher at Vedantu. Hello, Suchimama, Riya, Kalyani. Hello, Sai Telugu. Hello, Chinmaya. Hi, Mohit. Hi, Asil. Hi, Vishwa. Hi, Dilip. Hi, Bhargavi. Welcome. Good evening. Good evening. Join in, Bachalo. Join in, my warriors. This is Shreyas here, your physics master teacher, and I not only teach on the Enthuse channel, which is an exclusive English medium channel for all the aspirants for different kinds of competitive examinations like JEE, be it mains or advanced, or even BITSAT, KVPY, but I also teach on the regular Vedantu platform, and you can find plenty of my micro courses out there. So if you are interested in those micro courses, go check out one session which I had conducted a few weeks back, Shreyas Sir's Pro subscription, and you will find all those micro courses. I have been teaching for a very long time, and over this tenure of amazing experience of teaching, I have produced a lot of good ranks, and I really hope you guys are going to make me proud after 2 years when you're going to finally crack the examinations in 2023. And so that's the batch for JEE 2023, which we are calling it Nurture. So welcome all the 11th standard students, and we have already done so many chapters like vectors, units and dimensions, kinematics, integration, basic maths, 2D, relative, and right now we are in Newton's laws of motion, and this is the fourth session. And in case you want to watch all the missed classes, please watch it from the beginning. Do not try to hurry up the process and try to cover up things in a very short duration, because right now you are in 11th standard, you have time to actually study the chapters properly. So do not make a wrong choice of studying all the chapters in one shot, because this is a long-term batch for all of you. Hi Vishwa. Thank you, Kalyani, for making that promise and making us, probably will make us proud after 2 years. Chinmaya, probably all these students are 11th standard, so probably too early to ask them for a drop, and I hope nobody takes a drop out here. Hi, good evening, Jai, Cry, hi Ganeshwari. So all the new warriors, do not forget to mingle around, say hello, mark your attendance, mingle around with all the fellow warriors, say hi, hello, introduce each other, and yes, please make friends. Hello. So when will I reschedule yesterday's session? So Ria, yesterday's session is going to be conducted tomorrow at 2:30. Okay, so that's what has been done. I will be conducting a class tomorrow at 2:30 p.m. By the way, there is a very important announcement for all of you, especially for all the 11th, 12th and 3rd, the passing out students. So there are sessions which are going to be conducted, and there will be a preparation camp for all of you. Right from 19th of August to 22nd of August, there are lots of scholarships to be won. There will be free classes, there will be prizes, and also a test which will tell you how you are performing, and it's free of cost. You just have to register using the link which is there in the description box. So this is a preparatory camp for all the students, be it 11th, be it 12th, or be it a passing out student. Go check it out, guys. It's very important. You register yourself, and probably, who knows, you might just win some of these prizes. So different kinds of questions are going to be coming up. There will be tests, and if you do well, you might actually win a scholarship, and there is a big pool of money from which the scholarship will be given. In fact, the pool is around 10 crores if I'm not wrong. Okay, so these are the prizes to be won, like watches, drones, laptops, headphones. These are some of the examples. So guys, who knows, you might just get lucky. All right, so just give it a shot. Yeah, I will really hope that you guys do well. Very good. Kalani has registered. Hi Shiva, Ganesh. Hi Asuka. Hello. Oh, Shiva, my ad was super. I'm not sure which ad, but I'm guessing, yeah, the preparatory ad. Yes, I know. Okay, so I lose track of what and all I do. But anyways, this is the schedule for this week. It looks short because I was on a leave for 1 day, and plus I was involved in other activities. But I promise there will be a lot of sessions next week, guys. Okay, so in case you have missed the previous sessions, please check it out in the playlist which is there in our session or in our channel. Okay. No, Kalyani, I'm not tired. I'm not tired. Okay. Very good, Raghavan Tyagarajan. It's CR7. It's not cry. Oh, it's not cry. It's looking like cry when I see the chat box from here. Okay. It's CR7. It's like R2 from Star Wars. It's like the robo name. So you got a code name. CR7. That's nice. Bettina, depends on how you learn and how it's being taught. Bettina. So if you learn it properly, if you have that curiosity, and if you can do maths properly, and if you learn maths properly, and if you learn from a proper person, then for sure physics will be easy. So it's a combination of multiple things. It's not just one factor. Now here's the first question coming up on your screen. There is a Pandu and he has moved 6 meters per second. These are introductory questions. Slowly I'm going to come to the topic of non-inertial frame pseudo-force. So these are questions which you can answer based on your previous knowledge. If this Pandu moves 6 meters per second towards the right, Champa is at rest, she's standing over there. What is the relative velocity of Pandu as seen by Champa, and what is the speed of Champa as seen by Pandu? Come on guys, put up your answers in the chat box right now. What will Champa see Pandu doing? What will Pandu see Champa doing? Very easy answer. Let me know in the chat box. Hi Sachin. Thank you Jaswant. Hi Saraksha Chaudhary. Welcome aboard. Yes Riya, we have started. Come on. Kiran, you can post all your doubts in the doubt app, bacha. Right now, this is 11th standard batch and we are focusing on this session. So probably I don't want to break the flow. Okay. So Raghuvatanam saying 6 ICAP meters per second. And what about the second answer? So Pandu's velocity is very easy. So if Champa is at rest, Pandu is moving. What would be the velocity of Pandu with respect to Champa? It's very easy. Champa is at rest. It's clearly mentioned. Pandu is moving with 6 meters per second. So velocity of Pandu with respect to Champa, Pandu's with respect to Champa will be 6 I cap, and velocity of Champa with respect to Pandu will be, so if Pandu observes Champa, he will see Champa going far away. So negative 6 I cap. That's it, as simple as that. 6I and minus 6I. Simple, right? Very easy, straightforward question from relative motion. Everybody knows how to get this. Okay, like you can see, that's the answer. 6 meters per second right and 6 meters per second left. Fair enough. Now try to answer this question. You will slowly get to know what I'm trying to lead you to. I'm trying to lead you to a particular concept and you will understand it. Okay. So Annadurai, I would suggest if your percentiles are below 97, first focus on JEE Mains, bacha. Try to get 97 plus percentiles in JEE Mains and then start preparation for advanced. Trust me, if you do well in JEE Mains 4th attempt, probably will get into Eklavya batch. Plus, we'll also start the preparation once the JEE Mains is over here. Okay, cool. Try to answer this. If Champa sees Pandu moving relative to her, Champa is at rest, Pandu is moving, or maybe who is actually moving? What do you mean by who is actually moving? Hi Bhanu, welcome aboard. Happens, mistakes will happen, Suchi, and I'm expecting you guys to do a lot of mistakes in these questions. There are a lot of things to learn. Ashwara saying D, Kalyani saying A, Kamlesh saying B. Interesting, guys. Interesting. Moderate boy. What is this? Moderate boy. There is some extreme boy. There will be some mild boy. What is this? Something like a base, acid. Depends on the frame of reference. Okay, this lesson is easy. This lesson is in fact interesting. The correct answer is it depends on the frame of reference. Remember, I have told you that motion is always, motion or rest is always relative to something. Always relative. It is not, what is it not? It is not absolute. It's not absolute. There is nothing at absolute rest. There is nothing like absolute motion. You know what it means? I cannot say there is a rock in space which is moving at 100 meters per second. You will be like 100 meters per second. Fine, but with respect to what? There is always with respect to something. It may be with respect to Earth, maybe with respect to Sun. There is nothing like there is some, a foundation, there is some platform which is universally accepted as rest. No, there is no such platform or frame which is at rest as such. Keep this in mind. So it always depends on the frame of reference. Now look at the next question. It's slightly different. The Pandu has moved with an acceleration of 4 meters per second square to the right and Champa is at rest. So again, quick question. What's the relative acceleration of Pandu with respect to Champa and Champa with respect to Pandu? You might be wondering, sir, what kind of questions are these? Where is inertial, non-inertial, pseudo force? Hold on, you will understand something which nobody tells you, even in classroom. Trust me on this, you will get to know something very, very interesting towards the end of these quizzes. God, because of the name of the topic is there. Okay. Yes, Dama, my code is there in the description box, bacha. It is SHHPRO. And I think you should join ASAP, Dama, because the batches have just started, if I'm not wrong, this Monday, or probably just going to start this Monday. So there's a link for joining the 11th standard batches. SHHPRO is my code, bacha. Please get that discount. Thank you, Jaswan. Finally change the picture for me. Thank you so much. And do let me know whatever problems you have in the comment section after the video ends. Any specific problem, I'll definitely respond to it. Okay, cool. Zayed, join in. Nice to see your logo of Indian tricolor flag. Nice to see Independence Day coming up. Hi, Dharma, Sri Ram. Okay, come on. 4 and minus 4. That's obvious, right? Everybody gets this. This is 4 meters per second square to the right and 4 to the left. Because if you make Champa as the frame of reference, you will see Pandu going with 4 meters per second square acceleration. And if you make Pandu as the frame of reference, you will see Champa going this way with 4 meters per second square. That's obvious. Now comes the tricky question. Let's see how many of you get this. Everybody clear, I guess. Kamarasu, yes, you guys are late. Guys, those of you joining in late, first of all, I'm guessing you did not turn on the notification. First go there, hit the bell icon and choose notify all. Get all notifications. That's number 1. Number 2, you have to hit the subscribe button. And number 3, if you have done all this, please smash the like button to proceed ahead. Yeah, that's your Guru Dakshina for today's lecture for being conducted for free. So just do that. Yep. And here is the next question. Well, if Champa and Pandu see each other accelerating relative to each other, who is having absolute acceleration? Who has that absolute acceleration? Think about it. Yes, same answer, just the signs are changing, correct? Yes, Zayed, we are going to reach soon 1 lakh, but I'm also interested in your growth. I want you guys to score really well. Saja, yes, you're late, bacha, please. Remember, 7:30 Shreyas sir, always. Except there could be some exceptions, like in chemistry, there are always some exceptions. So sometimes you will also see me coming at some other times. Minion versus Champa. Depends on the frame of reference, says Dharanish. Zayed says Pandu. Kalyani says D. Saitalgo is also saying D. And nice to see so many of you changing your display picture to the We Enthuse Warrior logo. In case you want those display pictures like Jaswan, Kalyani, Saitalgo and so many others, there is a link where you can download that profile picture and upload it as your YouTube profile picture. That would be really, really cool. Okay, option D. How about this? How about this? What if I tell you that is wrong? Yes, that is wrong, and that's why today's lecture is important. The answer is depends on the net force. Yes. Now we're going to talk about this. We're going to talk about this. The correct answer is E. It's not on the frame of reference. That's what you should understand. And we will discuss this. But before that, let me also tell you guys and congratulate all the students who are scoring left, right and center in every board examination and every, competitive examination. I just got to know the Kerala board topper from Vedantu, West Bengal, a CET topper again from Vedantu, JEE mains, so many students got above 99 percentile and so many, not 1, 2, so many, 20, 30 students have got 100 percentile in their individual subjects. This is crazy, this is phenomenal, and this is 7 to 8 times more than the first JEE mains attempt, and this is truly marvelous because So many of you probably didn't know about Vedantu. So many of you did not know that you can actually learn online sitting at home, don't have to waste your travel time. And in just these few years, we have been able to build a community, build a platform, have these set of amazing teachers who can push these students, and their hard work along with the students' hard work and their motivation has brought us this phenomenal results in JEE Mains third attempt. And guess what? In fact, if you're not satisfied with that, we have VIP, which is Vedantu Improvement Promise, and that is if by chance you do not perform well when you join Vedantu and after you are completing the course, if there is no improvement in that, then the entire fees will be returned back. So that's something which is VIP. And so you should definitely consider joining Vedantu, because the chances of getting through all the competitive examinations like JEE, CET, boards, all of this with not just pass percentiles but with amazing percentiles is really, really high when you are in Vedantu. And the course prices are as low as 2,700 rupees per month. Obviously, you can recommend my code SHHPRO, where you will get 10% off either to your friend, relative, or use it yourself to save some money when you enroll in any of these courses. I'll talk more about it towards the end, but let's get going to the next question. Here is the next question. Thank you, technical girls. Yes, all is just increasing. Very true, Zayal. Okay, now how was the previous question's answer? Net force depends on the net force. You will understand it through this question. Observe this. Let's assume all the forces on Pandu are cancelling each other. On the Pandu, they are cancelling each other. And Champa sees Pandu relative to her. So who is actually accelerating? Think about it. Arvinder, you can choose your teachers, bacha, and the JEE batch is starting on 16th of August. Okay, 16th of August, the JEE batch is starting. And there are different batches. Like if you want, you will be automatically enrolled in the English batch. Okay, but if you want English batch, that is Hindi batch, you can also join that. Or if you feel that no, I want these set of teachers, then you can join those teachers. It's just a matter of selection. It's like Netflix. You can choose which movie to watch or which series to watch. So it's like that. So that's how pro subscription is. Okay, so many of you are saying B. Interesting. So who is actually accelerating? Now, how did you get the answer, guys? This is very interesting. Look at this. Correct. Very good. Proud of you, my warriors. Proud of you, my warriors. No, A can't be the answer. Pandu won't be the answer. Observe this. See, what did the question say? The question said all the forces on Pandu. Okay, the net force on Pandu is 0. Now, what does Newton's law says? If the forces are balanced, this is balanced. If the forces are balanced, then the object moves uniformly. There is no reason for it to accelerate. There is no reason why it should change its velocity, because all the forces cancel each other. So, hence, the acceleration of Pandu should be 0. Undoubtedly. This is non-negotiable. I hope we agree on this. But for Champa, there is a problem. There could be forces, I don't know, and only it's assumed that the forces on Pandu are cancelling. On Champa, it's not told. Maybe the net force on Champa is not 0. If the net force on Champa is not 0, that means it's unbalanced. The forces are unbalanced, and if it is unbalanced, the acceleration of Champa should be there. It will be there. She will be accelerating. So who is actually accelerating? Champa is accelerating. Although, look at their conversation. Champa will say, hey Pandu, you are accelerating with 4 meters per second square. Example. Pandu will be like, oh, is it? Pandu will look at Champa. He will also see Champa going away. Champa is also accelerating. Both will think. Champa will think Pandu is accelerating. Pandu will think even Champa is accelerating. Both will ask themselves, who is actually accelerating? Now, if they have attended my class, they know by Newton's laws, the person who experiences 0 net force is not accelerating. So, they will probably draw their free body diagram. I have taught you that in my first class. Drawing free body diagram, they will see, oh, this force, this force, this force, this force cancels. Pandu will be like, hey, the net force on me is 0, so I'm not accelerating. And you'll be like, hey Chamba, you are the one who is accelerating. I just drawn your free body diagram. And it says that your net force is not 0, hence you are accelerating. Do you get this idea? Do you get this idea, guys? Dhamma, small confusion. Hold on, I'm coming to pseudo force. Hold on for that. Everybody understood this? Everybody got this? So that's why the answer for the previous question is depends on the net force. Now comes the best line that I'm going to talk about in today's class. And that is this. It is possible for something to have 0 absolute acceleration. It is possible to have somebody or something or some object to have 0 absolute acceleration, but 0 absolute velocity is not even a concept. It's invalid. So it's very, very interesting to note this. Absolute velocity is not even a concept. We cannot talk about it. But absolute acceleration, yes, I can talk about it. Like, sir, how? Who is that frame or what is that thing which has 0 absolute acceleration? What is it? Because there is no such thing which is stationary. There is no such thing which has 0 velocity. So how are you sure that there is something which is not accelerating? I'll tell you, just open your eyes and look towards Pandu. You have just found that thing. All those bodies in this universe which have 0 net force. You draw the force body diagram and you see all the forces. Force by the moon, force by the earth, force by the sun, normal, friction, tension, spring, all forces combined, cancel each other, then such a body will have 0 absolute acceleration. And all those bodies like Champa who have non-zero net force, that is, there is some unbalance, they must be accelerating. I hope this makes sense to you. How many of you got it? Absolute. Absolute means not with respect to something. It's absolute. It's not with respect to something. It's like you have absolute scores and relative scores. So let's say you got 70 marks in physics. Somebody else got 80 marks. 70 is their absolute score. 80 is the absolute score. Relative, well, that's percentile. I scored 10 marks better than you. You are comparing. When you compare, that's relative. When there is no comparison, it's absolute. You have no thing to compare. That's absolute. Understanding this? Manojyoti, I have already made a video on basic maths. It's all there in the playlist. Let me know if you're not able to find it. Leave a comment. I'll definitely send you the link. Okay? Cool. What if the momentum is 0? Doesn't matter. Velocity is got nothing to do with acceleration. Change of velocity is acceleration. Rate of change of velocity is acceleration. So I'm saying there are objects, there are frames of reference which have 0 absolute acceleration. Everybody understanding this? Let me know by giving a thumbs up. What is the line I said? There are objects or frames which have 0 absolute acceleration, or I can calculate the absolute acceleration of any object. I can calculate the absolute acceleration of any object because there is a frame which has 0 acceleration. And which is that frame? The one which has 0 net force. The one which has 0 net force has no acceleration at all. That's what Newton's first law tells us in a way. So the concept that we learned through these questions is motion is relative, but acceleration can be absolute. Motion is relative, but acceleration can be absolute because you have a frame which has 0 acceleration. Now that's exactly what an inertial frame is. Imagine Pandu. Remember in the previous question, Pandu had 0 acceleration, Champa had some acceleration. So if, for example, I have a Pandu over here and I find that the net force acting on him is 0, therefore acceleration is 0, This is absolute. This is absolute acceleration. Then the Pandu's frame of reference, like if you make a frame of reference X, Y, Z, okay, and you attach it to Pandu, that will be called as an inertial frame of reference. What is it called? Inertial. It is inertial. Why? Because force is 0. So he is maintaining his inertia. So it is inertial. It's balanced. So he is maintaining his inertia. All frames of reference are called inertial frames of reference, which are attached to that. But let's say you have a champa over here. Okay, this is champa. Let's say, okay, cool. This is, okay. I hope she looks beautiful. Okay. And she's wearing this pretty hot red lipstick. And we find that the forces on champa, these are the forces on champa, and the force on champa is not 0. So acceleration is there. She is accelerating. Then that frame of reference attached to champa is obviously then called non-inertial frame of reference. What is it called? Non-inertial, because she is not maintaining her inertia. As simple as that. Now, can you think of some examples of inertial and non-inertial frames? I'm pretty sure you would have guessed some of it by now. See, simple guys. Earth. I'm standing on Earth right now. I'm an Earth observer. Am I inertial or non-inertial? Let me think. What are the forces acting on me? Well, I have my own weight which is acting down, and I'm standing, so I'm pretty sure I'm experiencing a normal. And this normal and my mg are cancelling each other. You might be like, hey, wait a minute. Probably there is a force of gravity by the moon and the sun. Well, that's negligible. And probably by other stars and Jupiter and Mars and God knows what. All those forces are negligible. So can I say the net force on me is negligible, almost 0? Is it almost 0? And hence can I say a ground observer will be inertial? So Earth frame of reference. Earth frame of reference will be inertial. Correct? This is one example. What if I am moving in a car and the car is moving with constant velocity? Car is moving with constant velocity, or train is moving with constant velocity. Think guys, what are the forces? Weight, normal, some force behind and some propelling force ahead. As the car is moving, so there is some force which is pushing it because it's being pushed ahead, and some force which is cancelling it out. Why is it cancelling out? Because velocity is constant. If velocity is constant, acceleration is 0. And if acceleration is 0, net force is 0. What is it? It's an inertial frame. So car moving at constant velocity, it's maintaining its inertia. It is also inertial frame. Is that understood? Similarly, just look at this example. What if you are in a train? Okay, this is a train. Okay, and this train is changing its velocity. The velocity is increasing. Is this inertial or non-inertial? Obviously, it is accelerating. There is net force acting on it. There is some force which is propelling and increasing its speed. Hence, net force not 0, acceleration not 0. It is a non-inertial frame. So I hope it makes sense. Similarly, if I have a lift, which is accelerating upwards. If I have a lift, I see, it's going up. It's having 1 meter per second, then 2 meters per second, then 5 meters per second, then 10 meters per second. It is accelerating upwards. Then also it is non-inertial. But if that same lift, where is my marker? Yeah, but if the same lift, if it is going up with constant velocity, well, then it will come under the inertial category. Why? Because it's going with constant velocity. Come on. It's inertial. Force up, force down cancels. Acceleration is 0. Velocity is constant. Keep this in mind. So the same object can be inertial or non-inertial depending on what exactly it is doing. I hope this is clear. Okay. So it's not like two types of inertia, Suchi Mama. These are frames of reference. All those frames of reference attached to those bodies where net force is 0 attached to those bodies where net force is 0 is called inertial, and attached to those bodies where net force is not 0, they are non-inertial. I'm not saying there are two types of inertia. Nah, that's not the thing. I'm talking about frames of reference. Okay. So inertial frame of reference is either which remains at rest or moves with constant velocity, like I told you. Such a frame can be attached to a body which experiences 0 net force. This is the main criteria. Do not forget it. That's why I highlighted it. Examples: car at rest, car moving with constant speed, or earth. All these are inertial frames of reference. Oh, earth is not revolving with constant velocity. Very good, Sajita. But the velocity is hardly changing with time. It takes a long time to change the velocity by 360 degrees. Precisely 365 days. That's a long time. So the acceleration is negligible. So we ignore it. We call it almost inertial. Take it. Yeah? Yeah. Okay, cool. So what about the graph? I don't know which graph. So if you're talking about velocity graph, it will be a straight line or horizontal line. If you talk about acceleration, acceleration will be flat, 0. Okay. What is a non-inertial frame? Earth is also approximated as inertial frame. I hope, Sajita, it answers your question. What is a non-inertial frame? All those frames of reference which is actually accelerating, where the net force is not 0. If the net force of not 0, then it is a accelerated frame of reference or non-inertial frame. Even if the direction changes, yes, Raghunath, the direction is changing, but it is changing slowly. That's why I said it is approximated as inertial, because it is 0, almost 0. Acceleration is almost 0. The earth is moving here, it moves like this, it moves like this. But it does not happen in 0.1 second, no, it takes days. So the acceleration is negligible. That's why it is approximated as 0. Okay, and you can see that the acceleration of a non-inertial frame, is taken always with respect to inertial frame. This line, try to understand it. What is an example of inertial frame? Example, earth. Example, earth. And non-inertial frame, example, accelerating car. So when I say the car is accelerating, what is it accelerating with respect to? Anything which is inertial, like earth. So usually you take inertial frames of reference as the point of view, but today you will learn that you can also shift your frame from ground to some other frame and still solve the problem. That's what you will be seeing. But usually when I mention the acceleration, it's always with respect to earth or such things which are inertial, which are moving with constant velocity or at rest. Okay, and I have given you the examples of non-inertial frame, like an accelerating lift or an accelerating train or an accelerating bus or a retarding bus or a bus or a car which is braking. All these are non-inertial frames of reference. Okay, great. Can we go ahead? Can we do some question? Let's see whether you can solve this question. And here it comes on your screen. A frame which is moving with constant velocity with respect to an inertial frame is, come on. Very good to know that this is your ultra productive week. I hope it remains like that. Maintain this momentum. That means if a car is moving on a road, is in non-inertial frame of reference, Manojyoti, if it is moving with constant velocity, it is inertial. If it is moving with acceleration, then it is non-inertial. Why acceleration is non-inertial? Because there will be some force unbalanced. That's why it will become non-inertial. So it depends if it is moving with constant velocity or acceleration. Okay. Oh my God, Chitra, come on, join in. You have missed a lot of discussion. Some of you are saying A, some of you are saying B. Interesting point. Let's see what you guys say. Well, the correct answer actually, Zayed, I'll be talking about pseudo force later on. Hold on, you need to wait. The answer is inertial, guys. See, why is it inertial? Think about it. A frame which is moving with constant velocity with respect to another inertial frame. So let's take this inertial as ground. Okay, this is, let's say, your ground frame of reference. Ground is inertial. Let's say this another frame, a frame. Let's say it is a car or a bus, example. Let's say it is also moving with constant velocity. Now, when I say ground is inertial, that means acceleration of the ground is 0. Correct? Acceleration of the ground frame is 0. That means it is inertial. And if this guy's velocity is also constant, that means this guy's acceleration should also be 0. Correct? So what does it mean? It is also inertial frame. Yes, as simple as that. Okay, I hope this makes sense. So all those things which have 0 acceleration, okay, will be also inertial. Cool. Now let's solve a slightly different version of this question. A small phrase is going to change. A frame which is moving with constant velocity but with respect to a non-inertial frame is what? A frame which, take examples and do it, guys. Take examples, trust me, then it will be easier. A frame which is moving with constant velocity with respect to a non-inertial frame is what? What do you guys see? Anything moving with constant velocity is the example of inertial frame. Manoj Jyoti, again, if it is, look at this question, not anything. Look at this. This is also moving with constant velocity, but still it could be non-inertial. And the reason why this is non-inertial is because that velocity is measured with respect to a non-inertial frame. So keep this in mind. If I have a frame which is non-inertial, that means the acceleration is not 0. Fair enough? So this is a non-inertial frame. Now I look at something, a frame which is moving with constant velocity with respect to this. If velocity relative is constant, think about it. The relative acceleration is 0. Agreed to this or no? The acceleration relative to this is 0. I'm seeing this velocity is constant, so relative acceleration is 0. Now, if acceleration relative is 0, what is the absolute acceleration? Think. I am seeing with respect to this red frame, this black frame has 0 acceleration, but red frame itself has some acceleration. So the actual acceleration of black frame will not be 0. That's what it is. I hope now it is clear. Is it clear? Yes. So you should understand everything. See, when it is inertial, it's simple. When it is inertial, I see somebody accelerating. Oh, that is non-inertial. I'm inertial and then I see somebody moving with constant velocity. Like, yeah, that is inertial. So if I'm inertial, things are very simple. I see something moving with constant velocity, I'll call it inertial. I see something accelerating, I'll call it non-inertial. But the moment you are non-inertial, then understand, even if that other frame is moving or is at rest with respect to you, understand the relative acceleration could be 0, but you yourself are accelerating. So if you yourself are accelerating, that guy is also actually accelerating. Hence it will become non-inertial, guys. Yeah. Balaji, Earth is approximately inertial. Like I have been telling you before, Earth is approximately inertial. Truly speaking, Earth is non-inertial, like I have mentioned before, okay? I hope you saw that slide. It is approximated. Zayed, try to understand this, bacha. If you are inertial, your Earth, your ground, you see something at rest. If you see something at rest, obviously that is also inertial. You see that thing accelerating, well, obviously that is non-inertial. But if you yourself are non-inertial, you are that Kida person, you yourself are non-inertial, and you see somebody moving with you, you will see probably 0 relative acceleration. That acceleration of that guy could be 0, but does not mean he is inertial. Why? Because you are measuring with respect to you and you yourself are accelerating. So that's why that person becomes non-inertial. I hope that makes sense. I hope this is clear. So understand, it's not so easy to understand or probably just say yes as soon as I explain you. You have to put in that effort after the session and try to visualize different scenarios. That's the only way you can understand this. Okay, cool. So a frame which is moving with varied velocity with respect to non-inertial frame. Dharan, I have made it as a homework question. So today's homework question is exactly what you have asked. Okay, chalo. Now, validity of Newton's law. Okay, circular motion, obviously non-inertial frame. Yes, it is, because your velocity is changing rapidly, obviously. So it is a non-inertial frame. Yes, okay. But in today's class, we are not studying circular motion. We have not yet started circular motion. We are studying translatory motion. Okay. Now, imagine three situations: train at rest, train accelerating, and train moving at constant velocity. Okay. Observe these three situations, and then you will see one interesting thing. Okay. My observer is this Pandu. This is Pandu. And let's say I call the person on the train Laddu, and she is basically your own Champa. Okay. Suji will talk about all the centripetal, centrifugal and all that later on. Don't confuse. Focus now. Now, in the first situation, who is observer and who is being observed? The Pandus, the Laddus and Pandus are the observers. These minions are the observers. This Champa is the object, is the person, is, the one whose free body diagram will be drawn. The forces will be drawn for Champa. Okay, let's draw the forces and see what do you get. First situation, the train is at rest, Champa is just standing on it. If Champa is just standing on it, nothing, I mean, like, there will be one force which will be the weight. Okay, that will be the weight, and there will be one force which will be the normal force. Everybody agrees to this? Everybody agrees to this. Thank you, Manojyoti. It became easy. Now wait a minute and you will see what will happen next. It's very interesting. Second situation. Train is accelerating. Champa is standing on the train. Maybe she is holding on to something. Maybe she is just standing, and she will move with the train. Everybody agrees? This Pandu and this train and this Champa, all of them are moving together. So obviously you will have the normal force. Obviously you will have the weight, and there will be some kind of force. I don't know, it could be friction, it could be normal, it could be some pulling force. I'll just call it P. So what is this? Or if you're getting confused, I'll just probably write it as friction, maybe. If the surface is not rough, she will slip, she will go bang onto the back door. So just think about it. If there is no friction and suddenly this room starts to move, I'll slowly go behind. You will see me go like this, and you will see me bang against that door. The reason why I'm able to move ahead along with the train is because my feet are getting dragged by the friction. I hope everybody agrees to this. Okay, cool. What else? In the third case, the train is moving with constant velocity. This is very interesting. Quickly think and tell me, apart from normal and the weight, do you think there will be friction on her feet when the train moves with constant velocity? Quickly let me know in the chat box. What do you guys say? The train moves with constant velocity. It's constantly moving with velocity. Acceleration? No. Do you think I should show friction on her feet? Yes or no? Gauri Shankar, Chitra, Manojyoti, Knowledge, everybody says no. Beautiful, amazing. I'm proud of you. There will be no friction because there is no change in momentum. They are maintaining their inertia. So if there is no retardation, no acceleration, why would you simply apply force, right? So it doesn't make sense. Great. Now, if I ask you to write Newton's laws in the x direction, so we are going to apply Newton's laws in x direction because there is nothing happening in y, okay, and see what happens in the first situation. Okay, first let's talk with respect to let's say over here we'll call Laddu, and over here with respect to Pandu. We are going to see what are the different theories by each one of them. Now, according to Laddu, Laddu is at rest, Champa is at rest. Okay, so the acceleration will be 0, the force acting will be also 0, and if he applies Newton's laws, F is equal to mass into A. Perfect. LHS is equal to RHS. Perfect, guys. I mean, this is not even a problem. LHS is equal to RHS because acceleration is also 0. Let's see what will Pandu say. Pandu will be like, yeah, there is no force. Yeah, you are not accelerating. So force is equal to mass into acceleration. Again, perfect. LHS is equal to RHS. Now let's look at this. situation and see what happens. First of all, let Pandu apply. Let Pandu apply, Newton's law on Champa. What will he see? He will see Champa accelerating with the train. If he just looks at Champa, he will be like, yeah, Champa is accelerating. So there is force. The force is the friction. Acceleration is also there. So he will be right. F is equal to mass into acceleration. Correct. LHS is equal to RHS. The force of friction will be mass of Champa into acceleration of Champa. Now let's look at Laddu. Laddu will be like Champa is with me. Champa is just right in front of me. We both are moving together. What is the acceleration of Champa? Think about it. What is the relative acceleration of Champa, guys? It will be 0. It will be 0, but the force is F. And this is the interesting part. F is there, mass is there, and acceleration is not there. And that means LHS is not equal to RHS. This is very bad. This is very bad. That's the problem. Now, if you look at the last scenario, because the velocity is constant, now with respect to Pandu, the force anyways is 0. There is no force. Acceleration is 0 since velocity is constant. Remember? So again, 0 is equal to mass into acceleration, and LHS is still RHS. And over here, with respect to this Pandu, the Laddu, Champa will have no force. Acceleration is not there. She is at rest. Remember that. For this Laddu, Champa is at rest. Both are moving with constant velocity. So 0 is equal to mass into 0. So LHS is equal to RHS. Do you see some anomaly? Do you see some exception? Do you see somebody breaking the rule? I'm pretty sure you have figured it out by now. This one, LHS is not equal to RHS. What has gone wrong over here? Yes, LHS is not equal to RHS. And the reason why it is not true over here is because in this situation, observe this Pandu. My God, I'm just highlighting him. He's really embarrassed now. He's highlighted. It's like, teacher in the class, hey, you, get up. So he's very embarrassed. Okay. So what is this Pandu up to? This Pandu, believe me, he is a non-inertial, he is non-inertial frame of reference. And if you are non-inertial frame of reference, yes, oh sorry, this is Laddu, my bad. This Laddu is non-inertial frame of reference, and that's why Newton's laws are not valid. All other situations, this Laddu, this Pandu, rest, inertial. This Pandu is always at rest, he is inertial. Even this Laddu is moving with constant velocity, so he is also inertial. Only this situation, this Laddu is non-inertial, and that's why Newton's laws are not valid. It's not valid. So you'll be like, oh, you must be feeling sad for this Laddu. Poor Laddu. All these situations, they can apply Newton's laws. This Laddu, in this situation, when he is accelerating, that is, when you are non-inertial, you cannot apply Newton's laws. You are feeling sad for him. Probably you are protesting about it. You are holding those placards and saying, hey, we want justice for Laddu. Justice for Laddu. So how do you get justice for Laddu, guys? It's very simple. Just create a magical force which does not exist just to make him happy. What do parents do? What do relatives do when a kid is crying? Hey, take this lollipop, put it in your mouth, chill, enjoy. And the kid is like happy, smiling. So let's give Laddu a lollipop, that's all. So you need to give him a lollipop, and that lollipop is a fake force, a non-existing force. It's just on paper to make him happy and just so that he can apply Newton's laws. Such a fake, fictitious, non-existent force which is just on paper, just to satisfy probably the ego, or just to make him happy, or just for you probably to make you happy, is called as a pseudo force. P-S-E-U-D-O. Pseudo means fake, non-existent. It's not true. That's a pseudo force. I hope this is clear. Okay, is that understood, guys? So I will create a pseudo force. I'll be like, Okay, what will this Laddu be thinking? This Laddu is looking at Champa. Hey Champa, you're just standing in front of me. And you are saying that there is a frictional force acting on you and towards this side. Like, you are at rest. How is that possible? There is a force here, there is a friction here, you are at rest. So, lollipop, what is that lollipop force? Pseudo force. Like, okay, the lollipop force is going to act that way and it is going to cancel it out. So, this force on this side, this will be called as the pseudo force, P-S-E-U-D-O, pseudo force. This is balancing it. Now, Laddu will be happy. Observe this. I'll just erase this. Okay, and I will just write it down this way. Observe carefully. The force acting on Champa will be F minus F pseudo, and that will be mass into acceleration. Acceleration is 0. Look at that. Why is acceleration 0? Because for this Laddu, Champa is at rest. So there is no relative acceleration. You are in the train looking at a person in the train. There is no relative motion. 0. So this is the net force is equal to 0. Therefore, I am going to get F pseudo is equal to F. But what is F? F is ma. Okay. So the value of this pseudo force, is nothing but m into a. That's it. That's what I got. So pseudo force is inertia? No, inertia is different. Inertia is the resistance to change the state of rest or motion. Pseudo force is a force. Inertia is in kgs. So don't confuse it with inertia. Yes, it happens because of inertia, but that does not mean it is inertia. Understand? Okay, I hope this is clear. So now my point is, what's the direction of the pseudo force? Let's think about it. Well, if I am non-inertial, I am accelerating towards my left side, pseudo force will always act opposite to the frame's acceleration. Do you see that? Number 1. If I am a non-inertial frame, I am accelerating on one side, the pseudo force always acts opposite to the frame's acceleration. Number 1. Number 2, the magnitude of the pseudo force is the mass of that object being observed. Here in this case it was Champa. So Champa's mass into A. A is the acceleration of the non-inertial frame. So mass of the object into my own acceleration, the observer's acceleration, is what is going to come in the magnitude. Alright, so let's write it down for you. Pseudo force. You experience it every time. You are in a train, you are in a bus. The bus accelerates, you are pushed back. From the bus's frame, from the train's frame, who pushed you? Nobody. But you want to explain it. You want to explain it on paper, you justify it via pseudo force. So if the bus suddenly accelerates, the force which you experience behind is not an actual force. It's a fake, non-existent, on paper force called as the pseudo force. So, oops, what just happened? Yeah. And that force is pseudo force. So it is nothing but, in non-inertial frames, your Newton's laws are invalid. So to make it valid in a non-inertial frame, we include a pseudo force. The direction, you can see it is negative A. You can see negative A. Why negative A? Because if the train is accelerating here, pseudo force will act here. But while writing equations, you will not put minus ma. You know the direction. You will always put the direction properly if you know the direction of acceleration. You will not put the magnitude as minus ma. Magnitude wise it will be ma. Vector wise, this is bold symbol, so it is minus ma. Okay. And then the final Newton's law, how will it look like? The final Newton's law will be other forces plus the pseudo forces is ma. What does this mean? What does this mean? See, simple guys. On this lady out here, there could be number of forces. I don't know. Somebody is pushing her, somebody is pulling her, God knows. Okay. So you draw all these forces. Okay. All those forces are external forces plus the pseudo force. The train is accelerating here. I show one more pseudo force. Okay. F pseudo over here. All these forces together, the pseudo force and the other forces, this is the total force is equal to mass into acceleration. That's it. As simple as that. Everybody clear till here? Yes. Everybody clear? Shall we start doing some questions? Only then you'll get some idea. You'll get the concept clear only if you are able to apply it. Thank you, everyone. All right. Cool. Clear. Thank you, Manojyoti. Okay, let's start solving some questions. Where are we? Okay, look at this question. Okay, now I will demonstrate this to you. Here I have a charger. I just plucked it out because nothing is charging. Somebody needed a charger, I guess. Somebody said 37%. Okay, I have this. Look at this. It's at rest. Do you see there is a tension in the wire? There is a tension in this cable. And why is there tension? Because this charger, this adapter has its own weight. So weight balances tension. We all know this. And I am pulling it exactly by the force of the weight of this object, assuming the mass of the string is negligible. So I am pulling it equal to the tension force, which is equal to the weight of the object. Cool. Now observe this. I'll just accelerate it like this. Look at what happens. I wish I could do this in slow motion, but if I do it in slow motion, then you will not see what is happening. Observe this. Do you see it just goes behind? Like, oops, my God, this charger just came out. Wait a minute. Yeah, let me just fix it. Thank God. Okay, so the moment I accelerate, it goes behind. Why is it going behind the moment I accelerate it? Reason, it has inertia. It wants to, it's like, no, I don't want to move here. The string is like, hey, come on, man. You're like, okay, fine, I'll move. So it goes behind. So there is an angle which is made by the bob. Now, if you are sitting in this truck or this bus or this car or whatever it is, you'll be like, okay, this pendulum was supposed to be vertical. You'll be like, what on earth made it go like this? This will be at rest for you. You are in the bus, you are in the train, and you see this pendulum going like this. You'll be like, what on earth just made it go like this? Because let's say you're unaware that the train is accelerating, you have to justify it. And let's try to justify it with free body diagram. Okay, don't worry, I'm not going to break anything. Okay, so let's justify this. My frame of reference is that train. Now help me with this. Is the train an inertial frame or is it a non-inertial frame? Quickly guys, let me know. Manoj Jyoti, I'm not interested in the answer. I'm interested in the solution, in the concept. I'm not at all interested in the answer. Just observe. Is the train inertial? Oops, Dharan. Observe it carefully. Moves with constant acceleration A. The train is moving with constant acceleration. How is it inertial, guys? How is it inertial? It is non-inertial. Observe it. It moves at constant acceleration. So the train is non-inertial frame of reference. Beautiful. Now if it is non-inertial, can I apply Newton's laws? No. Can I apply Newton's laws? Yes. What do I mean? I can use a trick. And what is a trick? Yeah, pseudo-force. Okay, let's apply pseudo-force. But before that, where is the train accelerating? It's accelerating forward. My knowledge says that pseudo-force always acts opposite to the frame of reference. So Chimama, the train is accelerating, as simple as that. So it is non-inertial, as simple as that. Okay, so it's clearly mentioned the train is accelerating. That's it. So it is non-inertial. Remember, non-accelerate. Anything which accelerates with respect to ground will be non-inertial. As simple as that. Okay, cool. Now, here is the thing. The pseudo-force will have to act backwards. Okay, so this is the pseudo-force. What will be the magnitude of that pseudo-force? The magnitude of the pseudo-force will be the mass of the object into acceleration of the train. What is the acceleration of the train? It is A. Don't put minus because you have already shown the direction. Don't be that stupid who puts that minus. It's not needed. It's already shown. Okay. Next up, what are the other forces? Well, one is the tension and second is the weight, which is mg. Achha. Let me draw some more lines which will help me solve the problem. Now the question is, what is the angle with the vertical? Okay, so think about it. If this angle is what we need to find, that angle and this angle will be the same angle. If this is theta, this is also theta. Everybody agrees? Okay, so I think I need to split the forces. Whom am I going to split? It's obvious. I'm going to split the tension into two components. One component here and the other component here. The one which is closer, adjacent to theta, that's T cos theta. The one far away from theta, that's T sin theta. Now it's obvious what to do next. Think guys, the tension's sin theta component. The tension's sin theta component minus the pseudo force. Okay, will be mass into acceleration. What is the acceleration of the bob? I am sitting in the train. I will see the bob at rest. So this is 0. Do you guys understand this? Why it is 0? Yep. So just take this guy on the other side and you will see T sin theta is equal to the pseudo force. Now what is the pseudo force? The pseudo force is mass into acceleration. So T sin theta is ma. That's what I got. These two forces are cancelling each other. Guys, this one is nothing but net force in the x direction is mass into acceleration in the x direction. What is the acceleration? 0, right? The acceleration is 0. Yeah, you can take the value of g as 10, but it is not needed. Bhargavi, I hope you understood it now. Okay, the acceleration with respect to train. Where am I sitting? I'm sitting in the train, not the ground. Be careful. Okay, now similarly, net force in the y will be mass into acceleration in the y. What are the forces? One is T cos theta, and downwards you have mg, and you have no acceleration over there. Now if you have no acceleration in the y direction because the bob is at rest, just shift it. So you're going to get T cos theta is equal to mg. Now clearly we know what to do next. From this equation and from this equation, just divide both of them. T sin by T cos. So T sin theta by T cos theta, just divide it. Tension and tension goes away in the next step, and here you will have ma by mg. M will also go, so therefore tan theta is nothing but a by g. Therefore theta is tan inverse of a by g. That's the answer. Great. Understood how to solve this? Yes. If the value of g is given, you can put it as 10 and check the options. If it is left in g, just leave it in g. That's it. Hello Mansi, welcome aboard. Give me a thumbs up if you guys are getting it, and yes, please do not forget to smash the like button down there. Okay, cool. Let's get going then. So this was the first question for you guys. Now let's solve more questions. But before that, let me tell you guys, if you want more problems for practice, if you want daily assignments, if you want your daily dose of assignments, problems, and you want tests, then please check out the test tab, additional content tab, where we conduct regular tests in our Vedantu app, where you will not only have to give those tests in a timed manner, but you also get detailed analysis, and you get the actual feeling of writing the JEE examinations, because they are all online. And not just that, exactly the same way how the JEE mains is conducted, same way along with the test analysis. Also, the best part about writing assignments in the Vedantu app is that you can come back to those assignments after some days. You can again re-attempt it, or if you are not able to attempt it, resume it, and you know which questions you have solved, what you have answered before. So you don't have to maintain a separate notebook for all the answers. And plus you can do the analysis of tests and assignments, compare them. All those data points are there. When you solve it in books, it's all haphazard. When you get a paper, you don't know, how did I do in this test? Okay, I just have a number. Or how did I do in this particular problem book or this assignment? I don't have a number. So when you get these numbers, it becomes easy to understand. Okay, so please check them out, especially if you're in the pro subscription. Thank you, Ria. Thank you, Asili. Got it. Now, 3 cases will blow your mind. Here it comes. Observe. Imagine you're in a lift which is ascending. It's ascending. Ascending means going up. Descending means going down. It's ascending with acceleration A. What will happen if there is a Pandu inside? Imagine you are inside that lift and that lift goes up, zoop. All the pseudo force on you. Oh, by the way, is this lift then a inertial or non-inertial frame? Tell me that. Is this lift inertial or non-inertial? Lift is accelerating. Whoa, two. Obviously, man, obviously it has to be non-inertial. Non-inertial, correct? Hence, pseudo-force. Where will pseudo-force act? Think, where will pseudo-force act? Accelerating up, pseudo-force opposite. That means downwards. So if there is a Pandu inside it, he will feel the pressure downward. He will be pushed down. And if he is standing by chance on a weighing machine, if he is standing on a weighing machine, is he going to see a bigger reading or a smaller reading? Will he see more weight on the weighing machine or less weight? Come on, think about it. Think about it. Thank you, Zed. Bigger weight, more weight, correcto, because pseudo force is pushing down apart from gravity, and that's what I want you to see, observe. So there is not only mg force but also the pseudo force, and obviously there is normal, and from this frame of reference you are at rest. Obviously this is non-inertial. This is non-inertial because you are accelerating with A. Hence, I would say normal, upward force minus mg minus the pseudo force, all the forces on the left hand side, is equal to mass into acceleration. This is 0 because this is at rest. So that's why this is 0. Okay, keep this in mind. Always on the RHS, it's the effect. On the LHS, it's the sum of the forces, considering the signs. Therefore, N will be mg plus the pseudo. You can see it is bigger than normal, and pseudo force will be mass into acceleration, so it is m into g plus a. So guess what? I can also write this down as normal is equal to m into g effective. So what is this g effective? This g effective in this situation turned out to be g plus a. This is more. He will perceive. Effective, this is what is perceived. So what is this basically? This g effective is what you perceive or effective. Okay, what is effective? What is the resultant? You will feel that way, that the gravity has increased. The Pandu is standing, you'll be like, oh, why am I showing more weight? Have I put on some weight? No, actually he has not put on. He'll feel, he'll perceive. That's why g plus a. Is that clear? Pseudo force can't be balanced by normal. It can be, depends. If mg was not there, then probably only normal will balance pseudo force. It is possible. But in this case, if he was on earth, there will be weight plus pseudo force that will balance the normal. Okay. So don't worry, Kalyani, you will be able to take a screenshot later on. Let's just hurry up because we have very little time left. That's why. Okay. Yes. If it was moving with constant velocity, correct, Sajita? Only when the velocity changes, that's when you will feel the change in the weight. But once it moves with constant velocity, you will not feel the change. Okay. Now look at the second situation. The lift goes down. The lift goes down. What will the Pandu feel? The Pandu will be like, पैरों तले जमीन खिसक गई. That means he will feel, in Hindi I told that phrase, those of you who understood probably can translate it. It means he will feel as if somebody took away the floor below his feet. It sounds ridiculous though. Well, I literally translated. Okay, so here is the thing. There will be one normal. There will be mg. The lift is accelerating downwards. It's non-inertial, of course. It's non-inertial. Because the lift goes down, pseudo force will be up. He'll be like, somebody is pulling me up. And when he feels that the pseudo force is acting, he'll be like, okay, let me stand on this weighing machine and see what's my reading. On earth, usually I weigh 50 kgs. What's my reading now? It will be less. It will be like 40 kgs. Like usually it shows 50, why is it showing 40? Where is that 10 kg going? Oh, that's because of that pseudo force. So pseudo force is the culprit. Understand that. Hence, in this case, I will write it down as normal plus the pseudo. Oops, the P is the silent. Okay, so in pseudo, you pronounce it as pseudo, but the P is silent. Remember that. Okay, okay. Pseudo force is minus this mg will be mass into acceleration. That acceleration, remember, will be 0. Okay, just move these things around. So normal is equal to mg minus the pseudo force. Okay, and this will be m into g, and pseudo force is ma. So this is m into g minus a. Interesting. And therefore I can write normal is m, g effective. In this case, what is g effective? G effective came out to be less than g. He will feel little bit lighter. If you accelerate down, you will be like, oh, I went up, and you will feel lighter. So he felt lighter because the lift went down. So g minus a is the effective acceleration. I hope this is clear. Everybody getting it? Okay. Okay, I hope. Oh, don't worry, you will not get the same. If you get 100 percentile, you will get the same phrase. Don't worry, Ria, I'm pretty sure you will feel much better than that. That feeling will be very, very different. I mean, probably nobody can tell you that feeling. It will be very amazing. I hope you get that feeling someday. What if the lift decides to accelerate more than the acceleration due to gravity? That is ridiculous. I mean, the lift is like, hey, acceleration due to gravity is 9.8 or 10. I will accelerate at 14 meters per second square. कुछ ज़्यादा ही पैरों तले ज़मीन खिसक गई. Meaning, your feet will be off the ground. Literally, in fact, the Pandu is going to bang his head on the top. He's going to bang his head. He's going to bang his head, truly. And the reason for that is because the lift is accelerating more. So if I have to write the force as this normal, and there is mg, lift is accelerating downwards, so there must be a pseudo force upwards. And this Pandu goes and sticks over there. His head bangs against that roof. And in this case, upward force, which is the pseudo force, PSEU dO minus normal minus mg is equal to mass into acceleration. Rearrange and you'll get normal is the pseudo minus mg, and in this case ma minus mg, therefore it is a minus g. Interesting. So in this case, can you see that your g effective has become a minus g, because a is more. If a was less, it will be g minus a. If a is more, it will be a minus g. And you will be like, sir, what if a is equal to g? Fine. If a is equal to g, will just float in that lift. Imagine that. The lift, somebody just cuts that cable. There is a cable which goes up on that pulley, there's motor and all of that. Somebody cuts the cable. Fine. That lift is going to just fall down with g. If the lift falls down with g, a is equal to g, g effective is 0, he will feel he is in space. He will feel he is in space, he is floating. He will throw an apple and that apple will be floating. He'll be like, wow, this is the best feeling in the world, I'm in space. It's marvelous. Amazing, right? How you can change how things are perceived. Yes. Did you guys understand these lift wale problems? So lift questions. Replay. So what's the bottom line out here? What's the bottom line? The bottom line is when you're in a lift, the bottom line is ignore there is a lift. Forget that there is a lift and solve the problem normally, like you would normally on the ground, because the gravity will change to either g plus a or g minus a depending on the direction of the accelerations. That's the bottom line. Everybody clear? Yes. I hope this is clear. Let's get going. Let's get going. Solve a question coming up on your screen. So let's see what is happening. Lift problem with inclined plane, block going down with kinematics. What more? Nothing more. Okay, let's try to solve this. The time taken by a body to slide down the inclined plane from rest, assuming what is that lift doing? It is moving down with retardation. Okay, this is interesting. This is really, really interesting. The lift is moving down with retardation. Raseez Ahmad, please watch proper lectures, full lectures. If you're watching one shots, trust me, you're doing injustice to physics. You're doing injustice to yourself. Do not watch one shots. You are one shot. I should probably write it down. One shots are injurious to health, like they put it on the cigarette packs. One shots are injurious to health, especially for all those students who are right now in 11th or in 12th standard. You are supposed to understand each and every bit of it. You have time, bachcha log. Hima will be coming to biotonic very soon. Okay, now let's see. If the lift is going down with retardation, that means while it is going down, the speed reduces. So earlier it was 5 meters per second, then it is 4, then it is 3. That means where exactly is the acceleration? Where exactly is the acceleration? The acceleration is actually upwards. Where is the acceleration? The acceleration is upwards. Dharam Rajan, I'll take some time, I'll take 1 more week, okay, to complete the chapter. Observe now. The acceleration is upwards. Understood, guys? Is this clear? Retardation means deceleration. Deceleration, reducing speed. So while going down, he is reducing speed. That means he is accelerating backwards or upwards in this case. Okay. Now if the acceleration is upwards, try to recollect Pandu's situation in lift. If the lift accelerates up, what will be the G effective? Okay, what will be the G effective? Quickly let me know, guys. What will be the G effective? Quickly let me know. What will be the G effective? Will it be G plus A or G minus A? If the lift accelerates upwards, if there is acceleration upwards, what will happen? Will it be G plus A or G minus A or A minus G? Think quickly. G plus A or G minus A? Exactly, Dharan. Very good, very good. Thank you, Darshan. Glad you got 99.67. This is amazing percentile, bacha. Thank you so much. Plus, very good. So the G effective will be G plus A. So, forget there is a lift. Forget the lift. That's the trick. Forget the lift and think like the normal problem. Instead of mg, you have mg plus a. Why is this g plus a coming, guys? Simple. Because apart from mg, you also have the pseudo force downwards. So that's why. Because the lift goes up, pseudo force always acts opposite. So that's why. And we all know for a block, what is the usual formula for acceleration? What is the usual formula for acceleration? Usual formula was G sine theta. Everybody remembers it? When a block is left on an incline, it accelerates with G sine theta. But G na raha. G did not remain G. It has been changed. The perceived gravity. What is the perceived gravity? It is G plus A. So wherever you see G, replace it with G plus A. That's the trick. Forget there is a lift. Replace G with the new G. And the new G is G plus A. That's how it is. And now solve the problem. Use your usual kinematic equations. S is ut plus half a t square. S is L. U is 0. It starts from rest. It's given. It's given somewhere. I don't know. You find it out. Yeah, it starts from rest. There it is. Okay, and half acceleration. What's the acceleration? G plus A. And there you go, sine theta. And write down t square. Just rearrange, shuffle it. Take 2 on the top, take these people downstairs. So t square will be 2L by G plus A. And there you go, you have sine theta. Therefore, t is root of 2L divided by G plus A. And you have sine theta, and that's the answer. Isn't it simple? Clear-o? Can we go ahead-o? Please let me know. Simple? Understood-o? How you replace a lift problem without a lift by considering G effective. As simple as that. That's all. Another question, guys, coming up on your screen now. Okay. Now this is not a lift problem. This is something else. This is not a lift problem, so you cannot use our technique there. But let's try to do this using pseudo force. Trust me, it's not that difficult. Okay, there is a block of mass m placed on a smooth wedge of inclination theta. The whole system is accelerating, blah blah blah. Read it out if you want, but I'll tell you what it is. There's this block on this wedge and you push this wedge. Somebody is pushing, accelerating. Now if you don't do that, what will happen? Think. If you don't do anything, this block is going to just slide down. Now if you pull or push this wedge this way, the block will go up. But that is if you pull it too much. If you pull it too much, this block is going to go like that and it's going to fall there. But if you just pull it right, if you just push or pull it and accelerate it right, it will try to fall down or try to go up, but it will be maintained in equilibrium. So it will neither go up, neither go down. It will just go like this. So, it will be at rest with respect to this wedge. And that's what the question is. So the question is, the block does not slip. So what should be the acceleration and what's the force by the wedge on the block? Is that understood? Premchand, gravitation will come later on, bacha. It's going to take a lot of time. It's one of the last chapters. Okay, but if you are urgently requiring gravitation, you can watch my 0 to hero and flash series. It's already been done there. Okay, first of all, if this guy is wedge is accelerating, this is acceleration of the wedge, think about it, what will be the pseudo force on the block? Yes, there will be, if I make the wedge itself as my frame of reference. So if somebody makes the wedge itself as the frame of reference, that will be non-inertial frame, and in that non-inertial frame I'm going to see the block at rest. I'll be like, yeah, I'm the non-inertial frame, the wedge is moving, accelerating, but for me the block is at rest. It will just stay stationary. Correct. Now there will be a pseudo force, obviously, and let's draw the pseudo force. Pseudo force always opposite acceleration here, pseudo force there. So pseudo force is here. This is the pseudo force. Correcto? Now normal force like this. Great. What else? Gravity. Don't forget gravity. mg downwards. That's it. Nothing else apart from that. It is at rest. All the forces must cancel each other. Somehow take components if you want. And let's do that. Okay. First of all, use my method of division by 8. Trust me, that will be easy for you. Divide it into 8 parts. Remember, I have taught you this. If this is theta, obviously this is theta, and this is theta, and this is theta, and this is theta. Everybody remembers that? Very good. Now let's resolve the forces, split the forces. Look at this, pseudo force is between these two blue lines. So one component of the pseudo force here, which will be F pseudo, cos theta, and this component will be the pseudo forces sin theta. Okay. Similarly, mg will also have a component here, and because it is closer to theta, it will be mg cos theta, and this component over here will be mg sin theta. Everybody clear? Check this out. If everybody is understanding this concept, let me know, guys, in the chat box. Let me know in the chat box if everybody got this. Then I'll go ahead. Okay, cool. Shall we go ahead? Okay, cool. Now, along the maybe incline, let's see what equation can I write? Along the incline. When I say along the incline, means in this direction. Okay. What is the equation that I can write? This force should be balanced by that force, obviously. So mg sin theta will cancel. Why? Because it is at rest. Will be balanced by the pseudo forces. Which component? Cos theta component. But wait a minute, I know the value of pseudo force. What's the value of pseudo force? The magnitude will be ma. Mass into acceleration. What's the acceleration? The acceleration is a. So it will be ma cos theta. And this would be mg sin theta as it is. No change. Gone. Cos by sine, or sine by cos is tan. So this will be tan theta, and this is g, and this is a. I think I have got my first answer. Yeah. What is the acceleration of the wedge? I think I have got that. That part done. Cool? Okay. So Nikhil, Bethi, I think you can watch the replay again, bacha. I hope you have seen my previous classes. I have taught this division of 8 method. That's a shortcut trick to get all the angles, and how to resolve forces I have taught in vectors, how to draw free body diagram first day, how to find the forces etc. on an inclined plane, also shown in the second class. So please watch those classes. Okay, probably that will be helpful. Okay, now here is the next thing. Once I get this, the last question is find the normal force. Find the force exerted by the wedge. The force exerted by the wedge means normal force. Let's find this out. Along the perpendicular to the incline. Perpendicular to the incline. What can I say? Perpendicular to the incline means, interesting, the normal force should be balanced by these two gentlemen down there, mg cos and pseudo. Do you see that? Normal will be balanced by these forces. So which is mg cos theta plus the pseudo forces. Which component is that? That's sine component. Interesting. So let's see what happens. mg cos theta plus pseudo force. Pseudo force is ma. So ma, and what is a? Wait a minute. A is nothing but g tan theta. I hope you understand what I'm trying to do. A is g tan theta into sine theta. Oh, that's interesting. So mg is common. Mg is common. So I will get cos theta plus tan theta into sine theta. That's sine square theta by cos theta, right? Because tan is sine by cos. Sine into sine is sine square. Now let's take LCM. So it will become mg. I'll have cos square theta plus sine square theta divided by cos theta. I know this identity. Sine square and cos square together is 1. So the final answer for normal will be just mg by cos theta or mg sec theta when I'm the same thing. So that's the answer for normal. Everybody getting it? Everybody understood how to solve these questions, guys? Please let me know in the chat box. Please let me know. Did you love this? And if you're loving this, please smash the like button. Correct. So that's how you need to solve this. Yeah. Oops, I don't know why the board is not working once again. Okay, I hope it works. Yeah, mg by cos theta and g tan theta. Correct. Now, if you have enjoyed this session, please solve these two homework questions. Drop a comment after the session is over. This is the first question and this is the second question. Let's see how many of you get it right, and post the answers soon, guys. And please watch whichever part you did not understand again and again. Now let me tell you guys, if you are interested in my courses, I'm conducting lot of micro courses for 11th standard like H.C. Verma. I'm conducting Irodov courses. Irodov is a very good book, Russian author for JEE Advanced. Okay, numerical problem solving. Okay, so these are slightly lesser than Irodov, but they are good problems, conceptual problems, and also derivation micro courses. These are just my micro courses. There are so many micro courses freely available apart from the long-term batches. Remember, our batches are in English as well as Hindi. The choice is yours. When you join, you're automatically enrolled in English, but if you want a Hindi batch, you can call up and write a mail to our support team. They'll immediately change your batch. You will obviously get teachers like me, or even better than me probably. Okay, and like I showed you, tests, assignments with lots of questions along with your Tattva module, which is a booklet. That booklet you will get it, hard copy as well as soft copy, and you will get all kinds of coaching even for KVPY. If you just want KVPY, there is a link in the description box for joining the KVPY crash course for PCMB. So you can check it out for SA students, because the exam is in November. You better start preparation because the batch is starting on Monday. Okay, so check out the pro subscription, guys, because the prices are very, very cheap. Like you can see, it's 2,700 rupees for light, and then classic, and then the plus goes till 5,400 when you use the coupon code SHHPRO, and you get 10% off. So the only difference, like you can see over here, all the things that I mentioned to you are there, everything. Live classes, test series, notes, doubts, etc, etc. If you want it on the mobile app, then you need to go for the classic version, and if you want the personal mentorship, then you need to go for the plus version. In personal mentorship, you have a dedicated person for you who will help you strategize and plan for the examinations and also counsel you. So that's something which you should look forward to. Really, guys, I'm truly excited to see you guys in the pro subscription under my micro courses. Thank you guys for being here. I hope you guys have enjoyed the session, and if you are enjoying the session, please don't be selfish. Share this video right now, call all your friends, and let's make this family big. And please do not forget to hit the subscribe button and smash the like button out there. This was your Capto, Shreyas. Bye bye. Take care. See you again next week. Hasta la vista.